Hey guys, so I have a nice, easy physics lesson for you guys today. We're going to go over what the definition of work is in terms of physics, then learn a couple new formulas and do a couple easy calculations. Okay, so for this lesson, we're going to go over what different requirements need to be met in order to say that work is happening. And then we're going to do some problems involving work. Lastly, we're going to define things like work input, work output, and change in energy. So when we say work in physics, what we mean is the amount of energy transfer produced by motion when a force is applied. So for instance, if I am holding a ball up in the air, and I drop it or I let it go, then the force of gravity is going to start being applied, and you're going to have a transfer of energy from gravitational energy to kinetic energy, which is just the energy of a non-moving object to the energy of a moving object. The formula is work equals force times distance. You can also use work equals mass times acceleration times distance, since force is just mass times acceleration. These are the three criteria that need to be met in order for work to be happening. So there has to be movement and displacement, so you have to move an object from one area to another. There has to be an applied force, so that could be like a push or a pull or something like that. And then the force and the displacement must be in the same direction. So for instance, if I were to hold something upright like this, I'm applying a normal force to the bottom of this object, calculator by the way. And if I were then to walk forwards with this, the displacement of this calculator would be in the forwards direction, but the force being applied is in the upwards direction. So that actually wouldn't be any work done to this calculator because the force and the displacement are not in the same direction. However, if I took this calculator and pushed it and slid it across my desk, now work is being done on the calculator because the applied force would be in this direction, and then the movement of the calculator, which is also in that direction, would be in the same direction, and therefore work is happening. So let's try some calculations. Okay, so for the first question here, we're just going to use the formula work equals force times distance. It tells us that the force is 20 newtons and the distance is 20 meters. So 20 squared is 400 is going to be the work that is done. Now, energy is always measured in joules. So because of that, work is going to be measured in joules. Because as we talked about, it's just a transfer of energy that is happening. Okay, for the second example here, we're given the mass, the acceleration, and the distance. So we're going to be doing work equals mass times acceleration times distance. Plug in our mass, plug in our acceleration, plug in our distance, and just multiply them together. 15 times 2.5 times 2 is 75 joules. Okay, next up, a couple definitions. So work input, also called energy input, is the amount of work or the amount of energy used to move an object a certain distance. That is what we're calculating when we calculate work using force times distance or mass times acceleration times distance. The object is going to gain energy because of the result of that work. So for example, if I take a calculator and I shove it, the energy required to move that calculator, however far it's going to move, is the work input. The kinetic energy it gains as it's sliding across the table would be the work output, or the energy output. If the force is constant, then if you graph force versus distance, it will be a straight horizontal line. And if you calculate the area of the shape under that line, you can also calculate the work input. That's not going to be something I'm going to ask you to do on a test, though. If there was no outside forces like friction, if there was just applied forces, then the total work input should equal the total work output. However, we don't live in a perfect closed system like that, and so we do lose energy, or an object will lose energy because of things like friction and air resistance. The work energy theorem says that work is energy expended when the speed of an object is increased or when an object is moved against an opposite force. So what it's talking about there is if I shove an object and it goes from not moving to moving, that is the speed of the object increasing, or if I am, again, shoving an object against the force of friction, or if I'm lifting an object against the force of gravity, all of those are energy expenditures and therefore work. When you do work on an object, the work is equal to the change in energy. So for instance, the work that I do to shove an object is equal to the change in energy of that object, like the kinetic energy that it gains by speeding up. The higher an object is above ground, the more gravitational energy it has. So the energy I use to lift an object against the force of gravity would be equal to the change in energy of that object based on the fact that it is now higher. We'll talk more about those different types of energy in, I think, the next lesson. Anyway, that is it for today's lesson.